Okay, now we're on to the back side of the note sheet. It's asking us again to find a greatest common factor of two monomials, this time back to 2. And so we're going to look at it in just the 3 parts. Every time we look at the coefficients and each of the variables individually. In this case, there's 2 variables, so that gives us a coefficient, the x's and the y's. So looking at the coefficients, pause the video, find your greatest common factor of the coefficients. Okay, welcome back. Hopefully you got the greatest common factor of 2. Next, we're looking at the x's. As we look at the x's, I see 1x here, 2x's here. What's the biggest amount of x's that I can circle in both of those? Okay, hopefully you thought 1. There's 1x here, 2x's here. The biggest amount of x's I could circle would be the 1x that I have here, because there's no more to circle. And there's at least 1 here, so I can definitely circle 1 in that term. And so I have an x as my greatest common factor of the x's. For the y's, we look here in the first monomial, there's 2 y's. In the second, there's none. If there's no y's here in the second monomial, there's no y's to circle here. So I can't circle here any as either because I have to circle the same amount in both. And so there's none. There's no common factor for the y's. As we write out our common factor, that's fine that there's no y's. We write out all the pieces, though, that we do have, which is the coefficient and the x. So we get a greatest common factor of 2x. Okay, hopefully you're kind of getting the idea now. Here we're going to do some work without the lead-in. So I'm going to actually leave that there. Without the lead-in and all the key things that you have to write down. So number 6 asks us to try this 4 times. We've got 4 parts to number 6. It asks us to find the greatest common factor of each of the monomials. So the steps are what we have written above. First, determine the greatest common factor of the coefficients. Once you've done that, then decide on your variables. So as we do that, we look at the greatest common factor of 3 and 81. You can check that on your calculator. Go ahead and pause and do that. Okay, hopefully you got a greatest common factor of 3. Then we look at our x's. There's 1x here, but there's none there. So I can't circle an x in both. I can circle one here, but then I wouldn't be able to circle that one here. So my greatest common factor for these 2 monomials is just the value 3. Okay, we're going to do one more together, and I'll let you do the next 2 on your own. So here we have m to the 5th, n to the 3rd. The second monomial is m to the 3rd and n. There's no coefficients, so I don't worry about my coefficients. Instead, I go to my variables. I start with my m's. There's 5 m's here, 3 m's here. If I were to think about expanding it and circling it, the biggest amount of m's that I can circle is the 3 m's that are in the second monomial. So m to the 3rd is part of my greatest common factor. Then I look at my n's. For my n's, I have 3 n's in the first monomial, 1 n in the second monomial. If I circle the same amount of n's in both monomials, I'd only be able to circle 1 because there's only 1 in this second monomial. And so m to the 3rd n is my greatest common factor for those 2 monomials. Okay, I'd like you to try this now. Go ahead and pause the video and try C and D. Okay, hopefully you were able to work those out. If not, I'm going to kind of walk through that here just to make sure. Checking my greatest common factor, we said take the 2 smallest numbers, find the greatest common factor of those, and double check to make sure it divides the 3rd. In this case, the greatest common factor of 4 and 10 is 2, and 2 does divide 20, so we get 2 as our greatest common factor. Looking at the x's, there's 1x here, 2x's here, and 1x here. The biggest amount that I can circle in each one of these monomials is 1x. Okay, looking at the y's, I have y squared, no y's, and 1y. Because there's no y's in the second monomial, there is no way for me to circle the same amount of y's in all of the monomials. So there's no y in my common factor. For part D, when you look to find the greatest common factor of 11 and 2, You don't find one. They say it's 1. So there's no greatest common factor. We can write a 1 if we want, but we really don't need to because we don't need a 1 in front of any variables. So we don't worry about our greatest common factor of the coefficients. There is none. Looking at the A's, there's 5 A's here and 8 A's here. That means I can circle 5 A's in each of those monomials. And looking at our B's, there's 9 B's here and 4 B's here. The biggest amount of B's I can circle in both is 4. So I have B to the 4th. Okay, that is my greatest common factor for those two monomials. Okay, now we have a couple of our questions that we want to look at, are multiple choice questions. These are similar to what we might see, these are a little bit on the hard side, for something on your, say, unit test. 7 asks, which pair of monomials has a greatest common factor of 2m squared? Okay, in order to start doing that, we want to think about that in pieces. First, I want to decide in the coefficients, which has a greatest common factor of 2. So pause the video, and I want you to cross off any options that have a greatest common factor other than 2. Okay, welcome back. Hopefully you crossed off A, you crossed off C. Those two don't have a common factor of 2 for their coefficients. So that helped me narrow it down quite a bit. Now let's look at our m's. I want to find ones that have a greatest common factor of m squared. Looking at B, I see 4 m's here and 1 m here. The biggest amount that I have in common is only 1 m. So B does not work. Looking at D, here I have m squared and 1m. Again, the biggest amount that they have in common is 1 single m, so that one doesn't work. Let's double check and make sure E works. M squared, okay, there's 2 m's there, and m to the 7th. The biggest amount they have in common is 2 m's. So here we have two monomials that have a greatest common factor of 2 and m squared. Okay, let's look at this last problem. Okay, we've seen a setup like this before. It asks which pair of monomials has the greatest common factor of 4x squared y. So here is our choices of monomials, and here we see the pairs. 1 and 2, 1 and 3, 2 and 3, 1 and 4, or 3 and 4. Okay, so let's start looking and seeing which pairs could possibly have a factor, greatest common factor of 4x squared y. So first we need to have a pair have a common factor of 4. So we're going to, again, start with that. Just look at the coefficients. Take a moment, check your pairs. Check 1 and 2. Check greatest common factor for 8 and 12, or 8 and 16. See if you come up with 4. If it's not 4, cross off that pair. Then check 1 and 3. Okay, and check all those pairs to see which one has the greatest common factor of 4. Pause the video and just check that piece, crossing off the ones that don't have a greatest common factor of 4. Okay, hopefully that went well. You should have crossed off 1 and 2. You should have crossed off, I think that might be actually it. 1 and 2 would be the only one with a non-greatest common factor of 4. Okay. Then we go on, oh, I'm sorry, nope, that's it. Now we're going to go on and look at the x's, just the x's. We'll worry about the y's in a minute. Greatest common factor of x squared. Let's look at 1 and 3. Okay, that's what our first pair says. 1 has the greatest common factor of x cubed, or has 3 x's. 3 has 1x. If I think about my greatest common factor, there's only 1 in 3. So with that only 1x there, we would only be able to circle 1x between the pair, and that does not work. Because 3 only has 1x, it can't be a part of any of the pairs because it's going to limit me to only circle 1x. So anything else that involves 3 can be crossed off. C and E. So hopefully, let's double check, make sure that works for D, for 1 and 4. 8 and 4 have a common factor of 4, x cubed and x squared. The biggest amount of x's is 2, so that's I can circle 2 x's. With the y's, we're hoping for only 1 y. Here's 1 y, and here's 3, so I can circle 1 y on both. And so we do get D is our final answer.